Hello students, hope you all have downloaded the PDF of the first chapter, that is measurement and dimension of physical quantity, from the Wasm app. So today we'll begin the next chapter, that is kinematics, and under kinematics we'll begin the first section, that is one-dimensional motion. So the most interesting thing of this chapter is the most of the things are already known to you. Okay, let's introduce the chapter first. So in physics we have a branch called mechanics, okay, where the science deals with the motion of different types of bodies and the effect of force on stationary and moving bodies both. And in mechanics we have two branches here, one is dynamics and other is statics. From the name you can clearly understand that in dynamics the motion of the body and the effect of force on the moving body is discussed here, and in statics we actually deal with the equilibrium of a body under the action of different kinds of forces. And the dynamics has two different sections, one is kinematics and other is kinetics. So kinematics and kinetics two are different things. In kinematics we only study the motion of the object, not the cause, and in that section where we discuss about the both the motion and also the cause of motion, that falls under the section of kinetics. Okay, so what one-dimensional motion is you already know. We have three types of motion here, first one-dimensional, then two-dimensional, and then three-dimensional. As an example, one-dimensional motion that is restricted only along a single axis, that is whenever a car is traveling along a straight line, that is one-dimensional motion. And when an object is moving on a plane, suppose an ant is moving on a book or on any surface, okay, so the two independent coordinates will be enough to describe or to identify the position of the ant at any instant. So this is called two-dimensional motion. And an object flying, if something is flying, then the kind of motion will be three-dimensional. Okay, next we have rest and motion. You all are familiar about rest and motion, and you already know that there is no such thing as absolute rest and absolute motion. It depends on the frame we are choosing. Suppose the example you already heard, in a moving bus, all the passengers, if you are inside the bus, all the passengers with respect to you is stationary, but someone standing outside the bus will be moving to you if you are moving inside the bus. Okay, so it's depend on where we are standing. With respect to you, all the passengers are stationary, but with respect to a different person who is standing outside the bus, all the passengers are moving, that is all the passengers are motion. So here comes the concept of frame of reference. So what frame of reference is? Here, whenever you are inside the bus, if you choose the entire bus as a frame of reference, then all the passengers are stationary. And if you consider the road or the region where the bus is moving as a frame of reference, then with respect to that frame of reference, the bus is moving or the bus is in motion, right? And whenever you are considering the entire earth as a frame of reference, all the objects are moving, right? Even a static object is moving, because the entire earth is moving and all the object on the earth is moving with the earth. So it depends on the frame of reference that we are choosing. The state of an object entirely depends on the frame of reference or the reference frame. In physics, to do all the calculations, we choose different types of frame of references here. Okay, the first one is the Cartesian frame of reference. You all have done the graph, right? You all have done graph in your mathematics. You all are familiar with the Cartesian frame of reference. Cartesian frame of reference is whenever you choose two or three independent coordinates that are perpendicular to each other as frame of reference. Okay, you all have done graph in your mathematics. In graph we have two independent axes. The one was x-axis, this was the x-axis, the horizontal one, and the vertical one was y-axis, right? So this is actually a Cartesian frame of reference to describe the position of an object in two-dimensional plane, right? But if we choose a three-dimensional plane or three-dimensional space, we will need another independent coordinate. We need another independent coordinate that will be perpendicular to both in x and y. So that axis is known as z-axis. So if you choose x-axis and y-axis along the plane, that is along a certain plane, if you are watching this video on your phone or PC or laptop or tab, wherever it is, if the x and y axis is along the plane of your phone or tab, then z axis will choose perpendicular to that surface. That means perpendicular to the display of your phone or laptop or tab, whatever you are watching the video on. Okay, so this is called a Cartesian frame of reference, where we choose three independent perpendicular coordinate as a frame of reference. You can easily understand that by watching at any of the corner of your house. Okay, if the two axes, the two corners on the ground, if one you choose as x-axis, other you choose as y-axis, so from that corner the height of the house will be chosen as z-axis. Okay, so how we used to define or we used to specify the position of a point in graph? By plotting the points. If the points are 2, 3, that means the point is, that particular point is at a distance of 3 unit from x-axis and at a distance 2 unit from y-axis. And if you choose a three-dimensional space, then you will need another coordinate, you will need another point to specify the position. Suppose it's 5, so you have to move 5 unit along the z-axis, and that point will be 5 unit distant from the plane you are choosing, your phone or laptop or PC or whatever it is. So this is how we define the position of an object in three-dimensional space using Cartesian frame of reference. Now we also have another frame of references like polar frame of reference or spherical frame of reference. Now all the frame of reference falls under two more categories, that is inertial frame of reference and non-inertial frame of reference. Okay, sometimes we describe or we choose a frame of reference with respect to another frame of reference. Sometimes we have to observe the state of an entire frame of reference, so we have to choose another frame of reference to describe the state of that frame of reference perfectly. Like if you choose the entire moon as a frame of reference and to specify the state of the moon, that is the type of motion of the moon, so we have to choose another frame of reference. So here you can choose Earth as another frame of reference. Okay, so there are two types of frame of reference here for these kinds of cases. First one is inertial frame of reference and the next one is non-inertial frame of reference. If one frame of reference is moving with an accelerated motion with respect to another frame of reference, then it is called non-inertial frame of reference. And if a frame of reference is moving with constant velocity or not moving at all, that is static with respect to another frame of reference, then it will be known as inertial frame of reference. Now next we have position. You know what position is. We have displacement here. You know what displacement is. We have distance here. You know what distance is. Even you all are familiar what speed is. Speed is the distance traveled by a body in unit time. Okay, so what is the new topic here? That is the instantaneous speed. Instantaneous speed, whenever the time interval is very little, very small, if you calculate the speed at that small interval of time, then the speed will be known as instantaneous speed. And if you want to define what instantaneous speed is, you can say that the limiting value of the rate of distance traveled with respect to time. Okay, what speed is the rate of travel rate of travel with respect to time. So the limiting value of the rate of distance traveled with respect to a certain time interval is instantaneous speed. So how do we define that? As you can see on the screen, Vi is the instantaneous speed. This is called limit, that is the limit, and the time interval is so small that the time interval is almost near to 0. That's why I have written it like this, that is limit del t tends to 0, and this is del L by del t, that is the rate of change of distance, and we are putting the limit before rate of change of distance. So that means the entire thing is the limiting value of the rate of change of distance, and that can also be written like this, that is dl dt. You will learn this entire thing in calculus section in mathematics. And next we have velocity. You know what velocity is. That is the rate of displacement of a body with time is called velocity. And here we also have instantaneous velocity. The same thing, just replace the distance with displacement. So what I have to do, just erase the distance here and put displacement. If I represent s as displacement, just put s here. Okay, so next we have acceleration. You know what acceleration is. Rate of increase of velocity with respect to time is called acceleration. And here we also have instantaneous acceleration, that is the limiting value of rate of change of velocity. So same thing, just put velocity in the place of displacement here. So put velocity here. This will give you the instantaneous acceleration, right? Now we also know that velocity is the rate of change of displacement, so we can also put the value of v over here, and if we put the value of v here, that is ds dt, it will look something like this. This is called the second order differentiation or second order derivative. You'll learn it in your calculus section in mathematics. Okay, next we have the equation of motions that you all have already learned in your class 9. The equations were, first one was v is equal to u plus at, where v is the final velocity of the object, u is the initial velocity, a represents the acceleration, and t represents the time interval. The next one was is equal to ut plus half at square, where u is the initial velocity, same t is the time interval, a acceleration, and s displacement. And the third one was v square is equal to u square plus 2a s, right? These three equation of motions you all have learned, even you have done the proof by both method, graphical and mathematical. Okay, but here in the syllabus of your class 11 you have another new equation, so let me write it first. So this is the equation, st equal to u plus half a 2t minus 1. First understand the equation carefully. What st is the displacement of the particle or of the object at tth time, okay? Suppose an object is moving with an accelerated motion, then the displacement will increase as the time proceeds, right? In each and every second the object will have different displacement here. As an example, the first second, at the first second the object, if the object covers a distance of 2 meter, in the next second, that is in second, the object will cover the distance of 3 meter. In the third second the object suppose covers a distance of 4 meter, and so on. So in each second the object is covering different distances because the object is moving with an accelerated motion. So if you consider, or if you can calculate how much the object covers in the 7th second, the time interval is 1 second. Remember that the time interval is 1 second. So how will you write this equation? To get the value of displacement at the 7th second, you will write s suffix 7. Here s7 doesn't mean that how much of distance the object covers in the entire journey, that is from 0 second to 7 second. Here what s7 means, at the 7th second the distance covered by the object, that means between the 6th second and the 7th second, that means at that interval of time the distance covered by the object is written as s7 here. So what st is? St is the distance covered by the object at between t minus 1 second and t second. So what we have to do, we need to prove this equation of motion, right? We'll use the graphical method here. So let's prove it, and first let's see the graph. So this is the graph here, that is the velocity time graph. You can clearly see that. So dE represent that time interval, that is the time interval is 1 second and it is between t minus 1 second and t second. You can clearly see that, and we all know that from velocity time graph, if you want to find out the displacement, you have to find out the area under the graph, the area of the region covered by that graph and x-axis. So to find out how much distance the object covers or how much displacement the object will have in tth second, so we will just have to find out the area of this particular region, that is the area of the region BDEC, and it's a trapezium. So how are you going to find out the area then? Let's find out. Now this is the formula of finding out the area of trapezium, that is half into sum of the parallel sides, that is dB plus EC, and the perpendicular distance between the parallel sides, that is DE. Here DE represent the time interval that I have already mentioned is 1 second, so we'll put 1 in the place of DE, and dB is the final velocity attained by the object at the end of t minus 1 second, and same EC will be the final velocity attained by the object at the end of t second, that is at t second. So we'll use the formula V equal to U plus AT for finding out dB and EC. So first let's find out dB then. If the initial velocity of the object is u, then to find out dB, using the formula u plus at, just write u plus a and that time, that is t minus 1, and EC we'll write u plus at, and we have to add these two. First take it out from the bracket, so you will have, just wait for a second, you will have at minus a. So whenever you are adding this, u plus u will make it 2u, and at plus at 2at, and finally a minus a. And if you put the entire value in this section, you will have something like this. So half multiplied by 2u plus 2at minus a into 1. So just take 2u out from the bracket, you will have u plus half, and take a common, u plus half a into 2t minus 1. So this is how you prove the formula using the graphical method. So that's all for this video. If you have any question, use the comment section, and please download the PDF from the Wasm app. And in the next video we'll begin vector. That's one of the most important chapter of entire physics. Till then, have a good time.